Hello everyone, welcome to another video of Advanced Mathematics of Class 10, Exercise 8.1, and we are going to do question number 4 and 5 in this video. Question number 1, 2 and 3 and also the theorem proof of theorem 8.1.1 have already been done in the previous video. So if you have any doubts, you can go ahead, watch the theorem 1, 2 and 3 and then come for 4 and 5. These are going to be easy sums, so you don't have to worry. Relax and have a watch at the video. Take a pen and paper so that you take down the notes as I go along the sums. So without wasting any more time, let's get started. So let us start with question number 4. So in question number 4, what we can see is there are two circles which intersect each other at the points A and B. Okay, so let us draw the two circles first. There are two circles which intersect each other at the points A and B. Okay, now there is a common tangent which touches the two circles at C and D. So C and D are the 2 points where a common tangent touches both the circles. We have to prove that CAD plus CBD. What do we have to prove? We have to prove that angle CAB plus angle CBD is equal to 180 degree. This is our two proof point. So how do we find it? First of all, let us join these points C and A and D, C and B and D, and along with it let us join A and B. So if I join A and B, here we have our diagram. Here we have to prove that CAB, which is this angle here, and CBD, which is this angle here. Okay, I'm sorry. We have to the CAD is this angle and CBD is this angle. Sum of these two angles is 180 degree. This is what we have to prove. So let's see how to start this. First of all, what we need to focus on is the theorem. So what are the theorems? The theorem states that it is alternate segment theorem. So what it states is the angle here formed by a tangent with one chord. So angle BCD, okay, BCD here, this is the angle formed by the chord CB with the tangent, the chord CB with the tangent, and this angle will be equal to the angle formed on the alternate segment, that is angle CAB. So BCD and CAB will be equal. Similarly, this angle here, angle BDC on the right hand side of the triangle, angle BDC will be equal to angle BAD, right? Because this is also the same theorem. We are having a tangent, a chord here. So tangent and chord are forming an angle, and this chord is forming an angle on the opposite segment here. So there we will have another angle, which two angles will be equal. So according to our theorem, what do we have is, if we start the proof, what can we write? We can write that by alternate segment theorem, what do we have in the alternate segment theorem? That angle BCD is equal to angle CAB. This is number 1. Also, angle BDC is equal to angle BAD. This is number 2. So we'll keep these two in mind. Along with it, we also need to see that if we add 1 and 2, if I am adding number 1 and 2, then what do I get? Left hand side will be added, that is angle BCD plus angle BDC will be added, and on the right hand side we get CAB plus angle BAD. So CAB plus BAD, what do we get? If I add angle CAB here and BAD here, a combination of these two will give me CAD, right? So on the right hand side I get angle CAD, and on the left hand side, if you look carefully into the diagram, sum of these two triangles here, sum of these two triangles, this B, this C and this D will be 180 degree. Sum of three angles of a triangle is 180 degree. That means angle BCD and when I add this to angle BDC, this must be equal to 180 degree minus angle CBD, because sum of these three angles should be 180 degree. So when I do a side change, when I take angle CBD on the right hand side, I should get BCD plus BDC equal to 180 minus CBD. If you are getting this, then in place of BCD plus BDC, from here, from this point, I can write it is 180 degree minus angle CBD. Now I just need to make one single side change and I will get the proof. 180 degree is equal to angle CDA plus angle CBD. So if I arrange it according to our proof, we will get, okay, this one I think I wrote wrong. This one will not be CDA, it will be angle CAD. Okay, so this will also not be CDA, this will be CAD. So CAD plus CBD, angle CAD plus angle CBD is equal to ultimately 118 degree, hence proved. So we just needed to use the theorem, which is, we needed to use the theorem of alternate segment, and we also knew, obviously we know that sum of three angles of a triangle is 180. So you use that theorem here in this small triangle BCD. We use that sum of three angles of a triangle is 180, and from there we got the 180 degree, and then ultimately by adding the two equations 1 and 2 we got to our proof. This is a very simple proof, very simple concept. You just need to know the alternate segment theorem. If that theorem is clear, which I have already explained in previous videos, if that theorem is clear, then you can come here and understand this. Moving on to our next question, question number 5. So what do we have in question number 5? In question number 5, it has been said, in triangle ABC, AB is equal to AC. So two sides are equal, that means the triangle is an isosceles triangle. Show that the tangent to the circumcircle of triangle ABC is parallel at A is parallel to BC. So there is a circle. Inside the circle we have a triangle ABC. Since it is said in the question, it is circumscribing the triangle. So inside the circle we have a triangle. The name of the triangle is ABC as it is given. Now there is a tangent at the point A. So I have to draw a tangent at the point A, and we have to prove that this tangent is parallel to BC. So let us give the tangent a name, let it be XY. So what do we have to prove? We have to prove that XY is parallel to BC. This is what we have to prove in this equation. Very, very, very simple sum. Okay, let us see the proof. What do we need to do here? We know the alternate segment theorem, and we also, it has been given in the question that AB and AC are equal. So first of all, since AB is equal to AC, therefore we must have the opposite angles are also equal. In an isosceles triangle, if two sides are equal, their opposite angles are also equal. So angle B and angle C must be equal. So we have angle ABC equal to angle ACB. Take it as number 1 and hold it there. Okay. Now coming on to the alternate segment theorem. Here angle XAB, angle formed by tangent XY with chord AB is XAB, and this must be equal to this angle ABC, alternate segment theorem. Okay, so here we have this chord, I made a mistake, not AB is forming a chord, an angle at C. So angle XAB should be equal to angle ACB. This is the chord, this is the tangent, and they are forming an angle here, and the alternate segment angle is angle ACB. So by alternate segment theorem, what do we have? Angle XAB is equal to angle ACB, which is number 2. Also at the same time we can write that YAC is equal to ABC, again the same alternate segment theorem. So we can write angle YAC equal to angle ABC. Equation number 3. Now if we look at equation 1, 2 and 3, in equation 1 we have ABC and ACB are equal. From 2 and 3 we see that ACB and ABC are here. So if the right hand sides are equal, then obviously the left hand sides will also be equal, right? If right hand sides are equal, left hand sides are equal, and AB and AC are equal, I mean ABC and ACB are equal, that means all the angles here, these 6 angles that we see here, these two angles, these two angles, and these two angles, all are equal. If all the angles are equal, then what can we write? We can write that from 1, 2 and 3, from 1, 2 and 3, what do we get? We can write that angle XAB is equal to angle ABC. Can we write this? XAB is here, XAB is here, and ABC is here. Since ACB and ABC are equal, XAB and ABC will also be equal. Now look why I have written this. Look into the diagram and you will see that where is XAB? XAB is this angle and ABC is this angle. What are these angles? If these two lines are there and this is the transversal, these two angles are interior alternate angles. And if the interior alternate angles are equal, that means XY and BC must be parallel, right? So that is what we will write. So since they are interior alternate angles, therefore XY should be parallel to BC, and hence we have done our proof. This is our second proof, question number 5. Another very easy sum. Hope you have understood it. If there is any problem, I would request you to go back a few minutes, watch the video, and then you can understand it clearly. So thank you everyone for watching. I hope you understood these two sums. I'll be coming up with the remaining sums in the future videos. I hope you stay tuned for those, and I'm really sorry for being so late in uploading these videos. I have been really busy with my new institute which we have started, which is Young Birds Academy. I think you have seen my other videos related to that as well. So I've been really busy, but I'm trying to come out now because the HSLC exams are very near, and I have been getting some requests where students are asking for the advanced mathematics questions. So I'll be trying to put out as many videos as possible on a regular basis. So hope I see your support. So thank you everyone for watching, and until next time, cheers.